Okay, good morning, everybody. Good morning. Good morning to our students in our Zoom class. Okay, good morning. Once again, hello. Do you
Good
hear
morning,
me?
sir. Yes,
Good
sir.
morning, sir.
Okay. Clear ba yung dating ko sa inyo dyan? Clear ba, mga kawer pa?
Clear, clear, sir.
Yes,
Clear.
sir. Clear.
Okay, sige. Okay, so we will continue our discussion regarding electrical principles, no? So our topic for today, to be specific, will be some portion of our current or our charges, and we'll be talking about resistance, no, for today. Okay, so good morning or good afternoon, good day, no, whatever time, no, you watch this video, no. So good morning to all of you, no, to our fellow Filipinos, no. This is actually study electrical engineering the Filipino way, no. So my name is Engineer Reggie Marinay, no. Just call me Kuya Reg, no. Kuya Reg is a Filipino language, no. That means a big brother, no. And then Kuya means a big brother, no, or your older brother, no? And your my name, just call me Reg, no? Kuya Reg, no? Okay, from time to time, uh, although I'll try my best to speak pure English, no? But there will be some portion of along the way I'll speak a little of our Filipino language, but do not worry to our non-Filipino friends, no, who are watching. Don't worry. I can assure you 100% that you will understand, no, the lesson for today, no. Okay, so good day to all our friends, no, to all our kawerpa, no. Do you know the meaning of kawerpa? So, kawerpa means kawerpa is a slang Filipino term, no? So, ka means brothers or sisters. Werpa is just the reverse of power, no? So, that's why it is kawerpa. Okay. So, I hope you can pronounce it also to our non-Filipino friends, no? Or audience. Okay, so good day. Once again, good day to our uh, Filipino students and non-Filipino students. So good day, no? Mga kawerpa, no? Okay. So let us continue our discussion on electrical principles. Okay. This is Mupasa, no? Okay, my favorite movie of all time, no? The Lion King. Okay. So we have a copper atom here. So copper atom, it has 29 protons, 36 neutrons, and it has uh, 29 electrons, no? Okay, so we have here, for the first shell, so we have here 2 electrons, no? And the second shell, it has 8 electrons. On the third shell, it has 18 electrons. And on the fourth shell, which is the valence shell, it has 1 valence electron, no? This is the valence electron. Okay, so we have a formula here to solve the number of electrons. The number of electrons in any or a particular orbit, no, is governed by this equation. So we have 2n squared, where n is the number of electrons on a given orbit. Small n is the orbit number, no? Okay, so our big N, I don't see any big N there. Okay, I'll just write it down here on the whiteboard. So our big N, okay, if we are to put our E, meaning that is the number of electron, that is equal to 2n squared. This is 2n squared, 2n squared. So this is the formula in getting the number of electrons at a particular shell. So let us have some sample. But before that, no, again, let us just review, no, of our principles, no. So the shell number 1, 2, 3, 4, 5, 6, 7, no, it corresponds to the shell number 1 correspond to K shell, number 2 is L shell. Number 3 is N shell. So on and so forth. The Q is shell number 7. Okay? So K, L, M, N, O, P, Q. So just like an English alphabet. No? Okay, so we have here, what is the number of valence electron of aluminum with atomic number of 13? So let us solve problem number 1. Okay, so the question here is, what is the number of electron with atomic number of 13? Okay, so let us have first the number of electron on the K shell. So on the K shell, let us have the number of, if I put this symbol, that means electron, no? So the number of electrons, no? Kasi the number of electrons. So we have here on the K shell, okay, on the K shell, the number of electron is, so we have here 2n squared. This is our formula. We have here on the K shell, so we have here 2 times 1 squared. So the answer is, of course, this is just 2. Okay, and then on the L shell, so we have here 2 times 2 because the L is the second shell. Okay, this is the second shell. So 2 times 2 squared. So this is equal to, so 2 squared is 4, no, times 2. So we have here 8. So we have here 2 plus 8, that is already 10. No? The value is 10. 2 plus 8 is 10. KL, let's have for the M shell. So the M shell. So what is the M shell? M is 2, then 3 squared. That is equal to, okay, so how much is this? So this is 3 squared. What is 3 squared? 9. Times 2, so we have here 18. But our given is aluminum. Aluminum has 13. The atomic number is 13. No? So if we have here 13, 18 is just the maximum number of electrons on the third shell. Okay? So for us to have 13, no? For the atomic number, meaning you have 13 protons and 13 electron. Okay, so we have 2 plus 8, we have 10. So just put here 3. Okay, so that, let us get the sum of 2 plus 8, 10, 11, 12, 13. There you are. No? So you have your 13, which is, this is our atomic number. Atomic number. So we have here 13. Okay? So let us draw the Bohr model, Niels Bohr atomic model. Okay, let's say we have here 13 protons. For the first shell, the K shell, is we have 2 electrons. So let us put here, there are 2 electrons here. Okay. And then we have for the L shell, so we have here 8. So we have to put 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 electrons on the second shell. Okay, and then on the third shell, okay, well, it can accommodate up to 13 electrons, but for us to have 13, because the atomic number is 13, so just put here 3. Okay, so we have 1, 2, and 3. So this is the atomic model of aluminum, no? Atomic model, no? That is the aluminum atomic model. Okay? That is the aluminum atomic model. So therefore, what is our answer for our question? This will be our valence. Number of valence electron. V E minus. That is the number of our valence electron. So the answer will be letter C. Okay. Then let's go now to problem number 2. Problem number 2, what is the net charge of a body that contains 8 protons and 4 electrons? 8 protons and 4 electrons. Okay, let's go here for number 2. Okay, so we have here, the question is the net charge, no? The net charge for number 2, net charge. The net charge is equal to the summation of the charges. Simply the summation of the charges, no? Okay? Please focus camera here. This portion. Okay. So we have here, what is given on our problem? So we have 8 protons. 8 protons meaning that is positive 8 because proton is positive in charge. Okay? The summation meaning you will add all the charges. But, by the way, before I solve the problem, there is a sign convention. Now, we have to take note of this. We have to take note. Okay? If you have a proton, meaning it is a positive Q. If you have an electron, so you have a negative charge. Okay? So let us get now our net charge. So that is equal to, again, we have 8 protons. So we have here 8 protons. 8 protons, and then that is positive. And then we have to plus, but we have 4 electrons. So we have negative 4. So the answer will be, this will just become a minus. So 8 minus 4, so we have here 4. That is the answer. That is the answer for our net charge. That is a positive 4. The value is positive 4. Okay? So the answer will be letter, positive 4 charge is letter B. Here. Okay? Letter B. Let's go over with problem number 3. Problem number 3. Okay. Take a look. So let us have first our given on our PowerPoint. Is focus here. Okay, a charge insulator has the efficiency of 50 times 10 to the 18 electrons. Find its charge in coulombs with polarity. So, find its charge in coulomb with polarity. Okay, so we have here our Q for number 3. So we have our Q that is equal to, so we are already given as 50 times 10 to the 18 electrons. Okay, so we have 50 times 10 raised to 18. No? 18 electrons. And then we have to divide it by the number of electrons per coulomb or per charge. What is the number of electrons? No? Let us use this value because many books uses this value. So 6.25 times 10 to the 18. This is the number of electrons, and this is also the number of electrons that is per coulomb, no? Per 1 coulomb or per coulomb. Take note that 1 coulomb is equal to 6.25 times 10 to the 18 electrons, no? Okay? That's too many. For 1 coulomb, you already have 6.25 times 10 to the 18 electrons. So if we are to divide this, electron unit is cancelled out. 10 to the 18 will cancel out also. So in your calculator, just press 50 divided by 6.25. What will be the answer? So we have 8 coulombs. Okay, the coulomb here will go up, okay, algebraically. So our unit will become coulomb. Coul is coulomb, no? Coulomb. Okay. That is the unit of charge that is in coulomb. Okay, number 4. Always remember that 1 coulomb is equal to 6.25 times 10 to the 18 electrons. Okay? Okay, so sa ating mga estudyante na nasa Zoom class, for our student in our Zoom class, so please open your video, no? So that our friends may see our Zoom class, no? Okay, so we have number 4. Okay, for number 3, so we have 8 coulomb. By the way, what is the answer? 8. So we have here 8 coulombs. Okay, so that is 8 coulomb. Do you hear me clearly, guys? Mga kawerpa, naririnig ba ako dyan? Okay, ha? Okay, mag-chat lang kayo kung hindi malinaw or humina na yung sounds, no? Okay, so. Okay, tuloy natin. So we have number 4. Let us review the meaning of electric current. Electric current, it is the rate of flow of charge. So we have the formula I is equal to Q over T. This is the charge per unit of time. T is the time which the current flows through a material. Okay, let us solve number 4. For number 4, let us read the problem. To find the current needed to charge a dielectric so that it will accumulate a charge of 20 coulomb after 4 seconds. No? 20 coulomb after 4 seconds. Okay, so again, what is the question in our problem? The question is the current. Find the current. Again, the formula for current is the charge per unit of time. Per unit of time. So it's just simply, what is our charge? The given is 20 coulomb. And then our time is simply 4 seconds. 4 seconds. So 20 divided by 4. So we have here 5. Coulomb per second is ampere. Always remember that. Coulomb per second is in amperes. Ampere. Okay. So 5. So the answer, it will be letter D. Huh? Okay, the one you see in our circuit breaker. Let's say we have 20 amperes, no? That is what we call the ampere trip of the circuit breaker. So we may say that there are 20 coulomb per second. That is the capacity or the ampere trip rating of our circuit breaker. No? So the 20 ampere meaning, so we have 20 coulomb per second flowing. No? Okay, that is the capacity of our circuit breaker. That is what we call the ampere trip rating, no, of our circuit breaker. Okay, so we have number 5. Okay, so for number 5, a current of 8 amperes charges an insulator for 3 seconds. How much charge is accumulated? How much charge is accumulated? So we have here number 5. Okay, let's go over here for number 5. Again, our current simply equal to Q over T. If we are to get Q, let us get our Q. Our Q simply equal to I multiplied by T. Okay? So that is I multiplied by T. Okay, and then, okay, always remember, no? Do not quit. Do not quit. Just like the word quit, right? Do not quit. Okay? Be a fighter. Okay. So, do not quit. Even though the funds are low. Okay? Do not quit. So, we have just to multiply. No? Let us just multiply the current and time. So, our Q is equal to we have our Q is equal to what? 8 amperes. So, we have here 8 and then multiplied by 3. So, our Q now will be equal to 8 times 3. So, we have 24 coulomb. 24 coulombs. There you are. So, the answer would be letter B. Okay, are you getting me? Can you follow our students? So, please, sana makita rin sila sa YouTube para makita na meron tayong estudyante. Okay, that's already highlighted, spotlighted. Okay. Okay, once again, so good morning to our viewers, no, in our YouTube live. So this is a live streaming, no, here in our country, in the Philippines, no. If there are any non-Filipino, no, who are watching, so good morning, everybody. So we'll try our best to make this in English so that everybody in the world may understand, no, maybe easily be understood our lecture. Although I have to apologize that I'm a Filipino, I'm not that fluent. No? Of course, there are many Filipino who are fluent in speaking English, no? But I'm sorry that I'm not one of them. Okay, I'm not one of them who are really very good at speaking the language. Okay, I'm just trying, no? We're just here to serve you guys, no? We just want to help all the electrical students around the globe. Okay, so we have now. Let's continue. Okay, yung ating mga pinakita na namin kayo. Pakibukas ninyo ang inyong camera. Billy and Patrick, no? Hindi magandang tingnan pag tayo. Paki-open lang. If there are any problems, so mag-chat po kayo dyan sa ating Zoom chat. Okay, let's go over to problem number 6. This is problem number 6. The electric charge that moves through a conductor varies in accordance with the equation Q that is equal to 800 P, where Q and T are given in microcoulomb and milliseconds, respectively. Calculate the current. So, let us calculate the current. What is the formula for our I? Once again, our I simply equal to Q over T. Q over T. Okay, by differential, our I simply equal to dQ. Okay, I will make this for the meantime small letter, dQ over dt. So this is our another formula. Okay, so we have dQ. We are given here the Q to be 800T. So our I here, it will be equal to dQ. So we have 800T. And then we have dt. Okay, what happened? What is the derivative of 800T? The derivative of 800T is just 800. No? The derivative of 5T is 5. The derivative of 3T is T. No? The derivative of 9T is T. Okay? That is with respect to T. Okay? So, well, if you are to take a look, just cancel this, no? Although it's not that nice to cancel this, no? Okay. So, just put here 800. Question. We have here 800. What is this 800? Take note that in our equation, the given equation, Q, we have here Q, that's equal to 800T. Remember that our Q here, it says here, okay, please put, okay, here. So, our Q is in microcoulomb. Our T is in millisecond. So, meaning, if we are to take a look at this equation, so this is Q divided by T. So we have here our 800. Now, what is the unit of Q over T? Of 800, I mean. That is the Q over T. The Q, again, is in microcoulomb. So put here microcoulomb. And the T is in millisecond. So, if that is in millisecond, we have to divide it by 1 times 10 raised to negative 3 so that it will be in second. So, please focus here. We have here 800. Okay? 800 microcoulomb. This is actually microcoulomb. Microcoulomb per millisecond. Just like saying, how many kilowatts do we have? How many kilowatts do we have? How many kilowatts? So we have here 10 kilowatts. So the kilowatts, the 10 has a unit of kilowatts. How many horsepower do the motor has? The horsepower of the motor is equal to 100. So what is the unit of 100? So that is horsepower. Automatic. Horsepower is equal to 100. Automatic that the unit of horsepower of 100 is in horsepower. One of my students would say in the exam, how many horsepower do we have? Horsepower is equal to 100 horsepower. Sir, why is it 100 horsepower? So, we can cancel the horsepower here. Okay? Do not cancel that. So, what do I mean? This is already given as microcoulomb and the time is already given as second or millisecond. So, the Q over T is equal to 800 microcoulomb per millisecond. This is the milli. 1 times 10 to the negative 3. Therefore, you put here in your calculator to be, you press in your calculator 800 micro. So, we have here 800 times 10 raised to negative 6. And then, divided by 1 times 10 to the negative 3 equals. So, therefore, the answer is 4 over 5 or 0.8. No, 0.8 ampere. So, that is the answer. No? So we have here, that is the answer. So we have here 0.8. The Q over T simply our I. No? So please show this one up. This one. Okay. There you are. No? Our I is Q over T. Then this is microcoulomb per millisecond. That is why the unit of 800 is microcoulomb per millisecond. There you are. So we have 0.8 ampere. So the answer would be letter. What letter is this? Letter A. Okay? That is letter A. Okay, so we'll go over our camera here so that our student may copy some of the notes here on the whiteboard. So you may, okay, on this whiteboard from number 3 to number 6 so that they may copy that. Although, we will upload this in YouTube, no? Of course, this is already in YouTube. You can, if you want to copy uh, what all the information, no, I wrote on the whiteboard. Of course, you may pause it, no, you may pause for a while, no, and then you may copy some solutions, no, in the YouTube, no. If you it's nice to go over again with our video so that you can master this topic, no. It's easier to learn, no, if you go uh, again and again for a particular topic. You may view it for the second time, the third time, the fourth time, no? If you're doing it, you'll become more efficient and you will appreciate more, no? These topics. Okay? So, you may easily understand these topics, no? If you go all over and all over again, you repeat, and then, of course, do not just watch. You apply. You study in your own and you solve problem in your own. Okay? This is nothing. This doesn't work. This doesn't work if you do not apply to yourself, if you do not explore. Okay? So this doesn't work. Remember that. If you're just viewing it in the YouTube all over and all over again, so that's nothing without your application. So you have to apply at home. Okay? You want to become Michael Jordan, Kobe Bryant, LeBron James. You have to develop the skill that they have if you want to be like that. Okay? You wake up at 4 a.m. just like Kobe Bryant. 5 a.m. he's already, 4 or 5 a.m. he's already in the basketball court practicing. Okay? You have to develop that skill if you want to be like that. Okay? Well, you can be better than me. No? I'm not that great. No? So you can have your own. I have a lot of students who are already board top-notchers. No? I'm not actually a board top-notcher. No. So you can be, that's the difference. If you want to become Michael Jordan, LeBron James, it's quite a bit impossible, or maybe the possibility is not that big. You become better than Michael Jordan. No? But you can you can achieve some of his achievement, just like what Kobe Bryant did. He want to become Michael Jordan, no? But still he has all the move of Michael Jordan. You see? So what I'm saying is aim high. That's what I'm saying. Okay, let us continue our discussion. Let's go over with resistance. Resistance. Okay, resistance, it is the property of material that limits the amount of flow of current and converts electric energy to heat energy. So that is a resistance, no? So if you want to know more detail, no, about these electrical principles, no, I want everybody to watch my discussion on Ohm's law, no, that was conducted last time. Okay, that's already been uploaded in YouTube. So I want you to view it, no. So we'll be dealing with the calculations of resistance this time, no. So ohm it is the unit of electric resistance named in honor of German physicist George Simon Ohm, no. So thank you very much to Mr. George Simon Ohm, no. So he is the one developed Ohm's law, no? One of the most important, no? That is our first law in studying electricity. Okay, we have the factors affecting resistance, the nature of material, length of material, the cross-sectional area of the material, and the temperature. So we have the following formula. This is a basic formula for resistance. So we have here R, that is rho L. Rho means RHO, RHO. No, it's a Greek alphabet, no? Okay. So rho L over A. Okay, so we have here R is equal to rho L squared over V. So R is equal to rho V over A squared. Okay, so where R is the resistance of the material, A is the cross-sectional area, rho is the resistivity or specific resistance of the material, then L is the length of the material, V is the volume of the material, and V is area times the length. What about that? So let us study the volume resistivity. Okay, please go over here. So we have here the volume resistivity. For example, we have a conductor here. Okay, with a length L. And there is a certain area here. That is the area. Of course, there is diameter here. This is the cross-sectional area. Okay? If we have a cutting plane here, this is what we call the cross-sectional area of the conductor, which is a circle. Okay, what is the volume here? So the volume, okay, so we have here the area multiplied by the length. You see, just like in geometry, in solid geometry, because this is a cylinder. The volume of a cylinder is simply equal to the base area multiplied by the length. Okay, so let us have now the area. Let us have first the area. What is our area? Area simply equal to V over L. And then we have our formula that is equal to rho L over A. So we have here our resistance. Let's go over here. So our R, that is rho. So we have here our L. I will put here, although it is L, so I will put here L over 1. Then our area is V over L. So V over L. Okay, by algebra, I remember my high school teacher. She taught us this principle, mathematical principle. So this is the extreme. That is what we call the extreme. Extreme. Those are the extremities and the means. These are the extremes over the means. Okay? What about L times L? So we have here L squared. 1 times V, simply V. That is why we have the formula rho L squared over V. Okay, got it? Now, again, by this formula, no? Let us get our L. From this formula, our L simply equal to V over A. So we have V over A. Okay? So we have here the formula of rho L over A. Rho, okay, we will replace the L by V over A. V over A. Okay, please focus here. Okay, so we have here our A because this corresponds to A, to L, huh? To L. Then our A is what? A rho L over A. I will just put here 1. Again, by mathematical principle of extremes over the means, so what do we have here? So we have V times 1, simply V. That is the extreme. And then the means, we have here A times A. So we have here A squared. Okay, so this is now the formula. R is equal to rho V over A squared. No? Let us say this is our number 3 formula for resistance. This is number 2 formula. And this is our number 1 formula for resistance. Okay? So let us solve some sample problems. Let us go over with the PowerPoint. Okay? But before we have our problem solving, I will discuss first, no? Because there are some portion in calculating the resistance that we need this topic, no, about the circular mill and the square mill of a conductor. Okay, we have the circular mills and the square mills. What is the difference between the two? So actually, what is circular mills? It is the area of a circle whose diameter is 1 mil. Take note, this formula, circular mill, so this is equal to D squared. D squared. Wherein our D is in mils. The unit of this is in mils. If we are to square the mils, so we'll come up with circular mils. 1,000 mils, that correspond to 1 inch. Or 1 inch, 1,000 mils. Remember that. 1 MCM correspond to 1,000 circular mil. Why, sir? What is M? Sir, mega. That's wrong. No? M is from the Roman numeral. No? What do I mean? What is B? That's 5. What is X? That's 10, right? What is C? Roman numeral. That is 100. Okay? Just like that. If we have big M, meaning that is 1,000. This 1,000 circular mil. Where D is the diameter of the conductor in mils. Okay. That is the formula. That is the formula of the circular mills. Okay. What about the square mills? I'll just show to you the square mills over here in the board. What is the area in square mills? No? The square mills is simply equal to pi over 4 d squared. That is pi over 4 d squared. Wherein our d is in mils, of course, no? That should be in mils. Okay? What is pi over 4 d squared? Actually, that is the area of a circle. Area of a circle. That is came from where? It came, what is the area of the circle? I remember in geometry, so that is equal to pi r squared. Pi r squared. Okay, so we have here the area that is equal to pi. But what is the radius? The radius is 1/2 of the diameter, right? So that is d over 2, so that is quantity squared. That is why we have to, this is pi. What is the square of d? So that is d squared. And then divided by, what is 2 squared? So we have 4. That is why the area will come up with pi over 4 d squared. Okay, got it? Did you get that? Okay, so we have this formula, and that must be in mils for us to get the square mil. That's the difference. D squared is the circular mil. Okay? So, you can see relationship between the two. What do I mean? What is this formula? That is our circular mil. So, that is equal to pi over 4. What is our D squared? That is the circular mil. There you are. This is a relation between the circular mil and the square mil. That is a relationship. Okay. There are, I'll give you trivia question. If we have 500 MCM, is that equal to 500 kc mil? Are they equal? Yes or no? I want to see our audience, in the Zoom class. I want to see them, everybody. Please spotlight them. Okay na? Okay, everybody, listen. I have a trivia question to all of you. No? So even to our viewers in our YouTube live, no? Because we are on a live stream. Okay, that is a trivia question. So what are they equal? 500 MCM, is that 500 equal to 500 kc mil? Yes or no? Yes or no? Anybody would like to answer? Anybody would like to raise your hand so that it will be interactive, no? Our system, this is the difference of our what we are doing here, no? This is an interactive way of lecture. Oh, Marlo, do you have any idea? Are they equal? Can you speak, Marlo?
Yes lang po, sir.
What?
Yes lang.
Yes, what is your wise guess?
Yes,
Are
sir.
they equal? Yes or no?
Yes, sir.
Yes. Okay. Okay, you spotlight all of them. I'll just count. Who said that they are equal? Will you raise your hand or thumbs up? Who said that they are equal? I'll just count. Okay, I will count. So there are only 1, 2, 3, 4, 5, 6. Only 6. 6 students. Okay, 6. 6. So meaning, how many are they? 9 participants? 9 participants. So meaning, there are 3 students saying that they are not equal. Actually, I almost already gave the answer because I discussed already some portion. Okay. But still, there are 3 participants or students, no? They did not raise their hand. These students say that MCM is simply equal to kc mil. The MCM is found in our Philippine Electrical Code. The kc mil is found in the National Electrical Code of US, of America. Are they equal? That is the question. Are they equal? Okay, I'll give my answer. What is 500 MCM? 500 MCM, I already discussed. What is MCM? M means 1,000. So we have here 500,000. Okay, this M signifies the 3 zeros here. That is 1,000. The cm is our circular mill. Is that equal to 500 kc mill? So, 500 K is 1,000, 1,000, and then the C mill is the circular mill. Well, it's just a matter of designating it. This is the big cm, and this is the small cm. But they are just the same. They are just equal. Okay? They're just equal. Okay, for us to be able to understand this topic, let us have some example. What is the size in square millimeter? This is the circular mill. Yes, anybody would like to speak? I'm hearing some voice. Any question there? Okay, so we have our example. What is the size in square millimeter of the cable 250 MCM size? Okay, partner? Let us convert this. Please listen carefully. This is 250 MCM. 250 MCM. Okay, we are going to convert this into square millimeter. There. Okay, so we have the 250 MCM. Okay, so that is a 250 MCM. 250 MCM. Of course, that is equal to 250,000 circular mil. And that 250,000 circular mil, of course, the circular mil is equal to D square, right? Let us get our D. And the unit will be in mils. Let us calculate. Okay, kaware pa, pakikuha nga natin. So we have the square root of 250. Okay, so the answer will be 500 mils. Okay? 500 mils. Okay. Let us have some conversion. So, we have here 1,000. Oops. In 1 inch, there are 1,000 mils. Okay? So, the mils will cancel out. The mils will cancel out. Multiplied by, let us convert this. This is the conversion. There are 25.4 millimeter per inch. So the inch here will cancel out. That will cancel out. So therefore, just go over with our calculator. Let us press 500. 500 times 25.4 and then divided by 1,000. Will come up with 12.7. That is 12.7. What is the unit? Millimeter. So let us get now the area in square. Okay? In square millimeter. So we have here pi over 4 d square. Right? D square. So we have to substitute here pi over 4, 12.7 millimeter. This is millimeter square. So let us calculate this one. So the answer will be 126.6768698. Right? Did you get that also, that value, guys?
Yes po.
This is our calculator. I hope you can see this, my final answer here. Can you see that? Can you see my calculator? Okay. To our non-Filipino audience, no, we are using the calculator of Casio FX 570 or 991 ES Plus. No? We may use that, but in the licensure exam, no, of, here in our country, in the Philippines, no, the Professional Regulation Commission, they approved the Casio 570 ES Plus. There is a first and the second edition that is approved. Okay? There's no difference with 991. Actually, I'm handling the 991 here. But if we are to take a look at the manual of 570 and 991, they're just the same. Okay? There's only one manual for 570 and 991 ES Plus of Casio. Okay? So, well, I believe that Casio is, you can buy this all over the world. No? This calculator. It's very helpful in our licensure exam. So we have, so the answer, 126.68, 2 decimal places, 26.68 square millimeter. So that is the answer. That's the answer. The answer will be letter, take a look here, guys. Letter C, 126.67. Okay, I will solve another problem. Actually, it's not found in my PowerPoint. I will add this sample problem. What about if we have a 500 MCM? 500. I'll put here 500 MCM. Let us convert this in square millimeter. Okay? Because that is the usual unit of the size of our conductor in square millimeter. Well, of course, we have, we call this the American wire gauge, no? The AWG. Of course, we have that. The AWG. Let's say we have here for AWG, I remember this is the American wire gauge or the Brown and Sharp gauge, no? And then this is the square millimeter, okay? Correspond to the square millimeter size. Let's say we have, this is number 14. Number 14, number 12 in AWG, in number 10, number 8, okay, number 8, so on and so forth, so on and so forth. Okay, so the number 14 correspond to what square millimeter? Okay, it corresponds to 2.0 square millimeter. Okay? Okay, please focus here. 2.0. What's the number 12? We have here 3.5 square millimeter. This is number 12 wire. This being used in our outlet. The 2.0 usually in our lighting system. The small circuit. Smaller circuit, 2.0 square millimeter. Then we have the 3.5, the more popular. The 3.5 square millimeter, that is number 12. For number 10, that is 5.5. No? One application is in our air conditioning system. So we have 5.5. And then the number 8. The number 8 here is 8 square millimeter. So 8.8. Okay? 8.8. Okay? Just like the song of Bayani, Agbayani. You know that? 8.8. Okay? So, this is 8 square millimeter being used in our service entrance. That's the minimum service entrance conductor in our building. I encourage you to see our lecture on building wiring installation. But that is in Taglish, no? It's more of a Filipino language, no? We will make some lecture video of my specialty topic in English so that our non-Filipino friends may see it in English version. Okay, that is a promise to everybody, no? Okay, so let us continue. So we have here 500 MCM, that is equal to blank square millimeter. Okay, so what is our 500 MCM? So our 500, well, let us equate this already. So this is already 500, what? M means 1,000. That is 500,000 circular mil. And then we have this square. Okay? Do you hear me, everybody? Thumbs up nga. Okay, clear tayo, ha? Okay. So let us get now the square root of 500,000. What is the square root? Okay? 500,000 square root. Press in your calculator. What is the value? Square root of 500,000. So 500,000. So the answer is 707.1067812. So let us round up to 2 decimal places. 707.11. What will be the unit, guys? That will be in mils. Okay? Mils. Okay, let us convert our D. This is 7.11 mils. Okay, let us have some shortcuts. Okay, I will rewrite this one here. I have no more space here. So, in here, so we have here 707.11 mils. This is in mils. And then multiplied by, take a look here, in number 7. Our calculation for number 7. Please take a look. Okay? We may have a bit shortcut here. So we have 25.4 millimeter per 1,000 mils. Again, let's take a look here. You see, in mils, so we have 1 inch per 1,000 mils. And then, multiplied by 25.4 millimeter per inch. Well, the inch will just cancel out, so we may go directly with 25.4 millimeter per 1,000 mils. Is that clear? Okay. So, we just have to cancel this one out. This one. Okay, what is the value for our D? Okay, everybody, let us calculate this one. 707.11, then times 25.4 divided by 1,000. Divided by 1,000. So the answer will be this 17.96. So this is 17.96 in millimeter. Okay, let us now get our area in square millimeter. So we have here pi over 4, and then we have 17.96 squared. Remember that this is in millimeter. So the area now will be equal to what? Let us have this. So my answer is 253.36. 253.36. 253.36. That's the answer. No? In square millimeter. Okay? What have you observed here? Will you focus here? I have a question to everybody. What have you observed with our values here? What can you conclude? Okay, students, please listen. What can you conclude? Anybody would like to answer? Please unmute now.
Look, let's
Anybody?
divide 2. Divide 2.
Okay, who is that? Who is that? So please, what's his name?
Leo, sir, Leo.
Okay, Leo. Leo. Okay, Leo, what is your answer? What is your conclusion? The way you look at it.
Look, let's divide 2, sir.
divided by 2. Okay, so let us have some relation. That is correct. No? If you have your 250, you have your 126. Okay, that is our final answer here. If you have your 500, you come up with 253. That is approximately 1/2, right? Okay, that is 1/2. So therefore, we can have a relationship between the MCM and the square millimeter. So meaning, if we have a circular mill, okay, right, for example, 250. So if we have a square millimeter, okay, so we have here our square millimeter, no? By the way, our circular mill, or shall we say our square millimeter? What is our square millimeter here? Square millimeter is equal to our MCM, that is over 2. Isn't it? Did you get that? Right, Leo? That is the relationship. If you have your 250 MCM divided by 2, that will give you around 125. That is very near to our exact answer here. Okay? If you have your 500 MCM, 500 divided by 2, that's around 250 square millimeter. Actually, those 250 square millimeter and the 125 square millimeter is found on the cable in the wire table. Okay? Being given by the cable manufacturer. You will see that. Okay? You will see the area of the conductor in square millimeter, no, or in MCM. So, if you see MCM just divided by 2, you'll come up with the area in square millimeter. Okay? Or, if you want to get the MCM, just multiply the square millimeter by 2. That's another relation. Actually, just the same. It's just the same. I'll just make this as square millimeter times 2. Okay? Just have to multiply. Just like if you have 125 times 2, that's 250. If you have 250 times 2, so you have 500 MCM. That's another relation. Actually, there's only one relation, this one. Okay? Is that clear? Did you get that?
Yes, yes.
Okay. So let us continue here. Anyway, you can really go back to YouTube, no? Once we finish all this lesson for today, no? So that you may copy all the details, no? What is I'm writing on the board. Okay, so let us go with number 8. This is number 8. A 400 circular mill, this is for number 8. A 400 circular mill cable is composed of 37 strands. What is the diameter of each strand? No? You see, what do we mean by strand? Well, strand is, if we have, let's go over here for number 8. The number of strands, just like this one, that one, well, in here, we are seeing here 1, 2, 3, 4, 5, 6, 7. So there are 7 strands. 1, 2, 3, 4, 5, 6, 7. So there are 7 strands here. Okay? Let's say if we have aluminum conductor steel reinforced. So this is all aluminum, 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 aluminum. ACSR. And this is the steel, the innermost conductor or the central conductor. That is the steel reinforced. Wherein our given is composed of 37 strands. So meaning, well, we are just seeing 1, 2, 3, 4, 5, 6, 7. So if we have 37, meaning, so there are more strands here. There are more strands there. What is the diameter of each strand? The question is, what is the diameter of each strand? Let's say we already have 37 strands. What is the diameter here of each strand? That is the question. Let us solve this first. Let us solve this first. So, let us get now the area of each strand. The area of each strand is equal to what? 400,000 divided by 37 strands. How many? $400,000, okay, then divided by 37 equals 10,810.81. 10,810.81. Okay? So what is the unit of this? So 400,000, that will be in circular mil. Circular mil. Okay? This is the area of each strand. Okay? Area of each strand. So, this is in circular mil, so that is simply equal to d square, right? So, we just have to take the square root of both sides. So, this is our d, which is equal to 103.98. This is 103.98 mils. Always remember, if we take the square root of circular mil, that will just become a mil or mils. Okay. So therefore, the answer will be letter. What is the letter? Okay. Letter A is the answer. Okay. Did you get that? Okay. So that's clear. Okay. I'll give you additional information. This is to calculate the number of strands. The total number of strands in a conductor. No? Let us put here total, or shall we say, this is the number of strands, no? Well, we can calculate, but for the total number of strands. What is the total number of strands? The number of strands, I will let that be ns. That's equal to 3x squared minus 3x plus 1. What is x? Wherein our x is equal to what? That is the number of layer plus 1. How is this? How is this? So we have for one layer. Let's say for one layer. Okay, let us have the number of strands. Total number of strands. We have 3. Remember this, no? If we have one layer, what will be our x? Our x is equal to, this is the number of layers. Since we have one layer, so let us put here 1. The number of layer is 1 because one layer. But there is plus 1. So therefore, our x is simply 2. Our x is 2. What is a layer? Let's go over here for number 8. Let's go over here. The layer is this. There is one layer here. That is one layer. If we have another conductor, you draw conductor here on the second layer. That is already the second layer. And then we have the third layer, so on and so forth. So you have 2. So you have here 3 times 2 squared minus 3 times 2 plus 1. So you'll come up with how much? So 2 squared is 4 times 3, 12 minus 6. So 6 then plus 1. So we have here 7. What does this 7 signify? This 7 is the total number of strands for one layer conductor. For one layer conductor. Okay? Take a look here again. I just draw a 7 layer. I just draw a 7 layer here. The 7 here is this 7 conductor. 1, 2, 3, 4, 5, 6, 7. Let us go back with X. What is our X? That is the number of layer plus 1. What is this 1? This 1 is our central conductor. Okay? That is our central conductor. That is the conductor at the center. Only one conductor at the center. Central conductor. Okay? That's why we have plus 1 here. So we have 7 for one layer. What about for 2 layers? What is our X? Well, so we have here 2, put here 2 plus 1, just add 1, always add 1, so we have here 3. So the total number of strands for 2-layer conductor is what? So we have here 3 times 3 squared minus 3 times 3 plus 1. So you will come up with, how much is this? This is 9 times 3, 27 minus 9, 18 plus 1. Is that 19? Is that correct? So 9 times, this is 9 times 3, 27 minus 9, 18 plus 1, 19. Okay, that's correct. Okay, for 3 layers. For 3 layers. For 3 layers, what is our X? We have here 3 plus 1. So we'll come up with 4. So the total number of strands is equal to, so we have here 3 times 4 squared minus 3 times 4 plus 1. How much is this? So this is 16 times 3, 16 times 3, 48 minus 12, 36 plus 1. Oy, we have here 37. Well, actually, this is our given, right? This is our given. 37 strand for number 8. Meaning, if we have to consider, we have here 19 for the second layer, you will add how many? Minus 7. 12 conductor. You will add 12 conductor here. You have to add 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 conductor. That is for the second layer. And then for the third layer, you will add another sets of conductor here. So there are 37. Okay, did you get that? That is the total number of strand of a given conductor, no, or cable. Okay. So we have number 9. Let us go over with number 9. Okay? Let us go over here. So I'll just erase the board. Okay, so we have for number 9. A coil of annealed copper wire has 820 turns. The average length of which is 9 inches per turn. Okay? So there are 820 turns, no? On the average for each turn is 9 inches. If the diameter of the wire is 32 mils, calculate the total resistance of the coil. No? What is the total resistance of the coil? Okay, so we have here for number 9, So our formula, again, for our resistance is simply equal to rho L over the area. Okay. Our rho, actually, well, you have to memorize this. 10.37 ohm circular mil per foot. That is the resistivity for copper. Resistivity for copper. So, let us have now the length. The length. How to calculate for the length? We have here 820 turns. 820 turns. And then multiply by what? 9 inch per turn. 9 inch per turn. And then multiply it by what? Let us convert this into feet. In 1 foot, there are 12 inches. 12 inches. So, let us cancel out our turn. Here, then our inch. So, what will be left is feet. Okay, let us multiply 820 times 9 divided by 12 equals 615. 615 feet. That is the length already. That is the length. Huh? Okay, so we have here our area in this square because that is in circular mil. We are given 32 mils, no? 32 mils. Remember, this is in mils, no? Let us square this. We'll come up with circular mils, right? Let us have our calculator. 32 times 32. Okay, so there are 1024. 1024 circular mil. So, we can now calculate because the question is the resistance. We can now calculate. Let us substitute in here. So, we have 10.37. This is ohm circular mil per foot. Okay? And then multiplied by, that is our rho. Our L is 615. 615 feet. Okay? 615 feet. That is our L. Our area is what? 1024 circular mil. Okay? The feet will cancel out and also the circular mil. What will be left is just simply the ohms. No? Okay? So let us calculate 10.37 times 615 divided by 1024 equals 6.23 is our answer. 6.23 ohms. That is our answer. Okay? The answer will be letter C. Okay? Very easy. Okay? That's very easy. Okay, number 10. No? Okay, so go over with our whiteboard first so that some of our students may copy it. Okay, so let us calculate now number 10 problem. Let's go over with number 10. A steel of the third rail of a railway system has a resistivity of 21.4 micro-ohm centimeter. If its cross-sectional area is 8.2 square inch, calculate the resistance per mile of the rail, no? You have a railway system, no? You have a rail, no? Do you see the did you imagine the railway, no? The rail of a railway system. So it's something like this one. Okay? So this is the cross-sectional area of the rail, no? Okay? Of a railway system. Okay, so let us have first for the area. So we are given here the area. The area simply equal to what is our given? That is 82 square inch. Okay? So 8.2, I mean, sorry, 8.2. 8.2 square inch. The 8.2 square inch, so we have here 2.54 okay, centimeter per inch. So this is in square. We have to convert this in square centimeter. Why? Because our resistivity is in ohm centimeter. Okay? Is ohm centimeter. So let us convert. Let us convert. So we have 8.2, 8.2, and then times 2.54 x squared equals. So we have 52.9 square centimeter. The area is equal to 52.9 square centimeter because the square inch will cancel out, right? There you are. Okay, so we have the length. Calculate the resistance per mile. So meaning, we have the length for 1 mile. We have to multiply it by 5280 feet per mile. So the mile will cancel out, right? This will cancel out. Okay. So we have here, there are 12 inches per foot. And then we have 2.54 centimeter per inch. Okay, let us manipulate this one. We have 5280 times 12 times 2.54 equals. So the answer will be 160,934.4. 160,934.4. What is the unit? Again, the unit, the mile will cancel, the feet will cancel. So this is in feet, cancel, inch will cancel. Okay, so we'll come up with centimeter, right? This will be the centimeter. So, well, for the resistivity, we are already given. What is the resistivity? 21.4 micro. Okay, I'll go directly with our formula. I will just substitute. What is our rho? Our rho is 21.4 micro. Micro means times 10 to the negative 6. Okay, micro ohm. This is centimeter. Okay? This is the rho. What is the L? We have 160.34.4 centimeter. Okay, rho L over area. What is our area? So, we already have the area 52.9 square centimeter. We already calculated that area. So, the square centimeter will cancel out. So, we have here centimeter square. So, we have centimeter, centimeter, centimeter square. And then we have cm square here. Okay? So, what will be left is just the ohms here. Right? Did you get that? Okay, so what is the answer? Let us manipulate this one. So 21.4 to the exponent negative 6 and then times 160,934.4 then divided by 52.9. So that is equal to 0.065. Okay, did you get that? 0.065. R is equal to 0.065 ohms. What is the letter? Let's take a look at the PowerPoint. What is the letter of our answer? Okay. The answer would be letter D. Okay. Letter D. Okay, let's go over with what number? We are now on number 11. Number 11. Okay. Number 11, so we have a coil of copper wire has a length of 600 feet. 600 feet, copper wire. What is the length of aluminum conductor if its cross-sectional area and resistance are the same? Cross-sectional area and resistance are the same, as those of the copper coil. So we have aluminum, we have copper coil. Okay? So we have the formula. By the way, we have to note this. The ohm circular mil per foot. The ohm circular mil per foot. Now for number 11. Again, the resistivity for copper. So we have, like before, we have 10.37 circular ohm circular mil per foot. Okay? And then in our problem, so we have for aluminum, For aluminum, so our resistivity is 17 ohm. For aluminum, 17 ohm circular. This is circular, this is not centimeter, This is ohm circular mil. Okay. So this is ohm circular mil per foot. Okay? There you are. So we have the formula for resistance. What is the formula for resistance? Rho L over the area. Okay? So take a look here. I will cross multiply the area to the resistance. So we have here RA. That is equal to rho L. To rho L. R times A is equal to rho times L. Take a look here, guys. Let's go over with our PowerPoint. You will see here if its cross-sectional area and resistance are the same. Okay. Cross-sectional area and resistance are the same. Take a look here. This is the cross-sectional area. Okay, please focus more. And this is the resistance. More. Okay, this is the area, this is the resistance. We may replace this as constant K because that is constant, doesn't change. That is said in the problem. Now, we have here constant K, so that is the resistivity multiplied by the length. Okay, so if this is for copper, what is the question in our problem? What is the length of an aluminum? Okay, let us have first for the aluminum. The rho for the aluminum, length of the aluminum is equal to the rho of the copper. Okay, this is aluminum. Okay, then the length of the copper. Okay, let us put here. So the question here, what is the length of an aluminum conductor? So this is the question. This is the question. What is the length of this? What is the resistivity for aluminum? We have here 17, I mean, sorry, 17. So put here 17, the length of the aluminum. So, what is the rho for copper? 10.37. What is the length of copper? What is said in the problem? No? A coil of copper wire has a length of 600 feet. So put here 600. Okay? What is now the length of the aluminum? Let us calculate this. 10.37 times 600, then divided by 17 equals. The answer is 366 feet. Did you get that? 366 feet. That is our answer. Okay? 366 feet. Okay, you may copy it. For the meantime, I will erase the board. Please focus here on this whiteboard. Okay. What number are we now? Okay, for number 11, so our answer is letter, okay, that is letter C, no? 366. Okay, let us go over with number 12. Number 12, so we have here, please focus here, number 12, a certain wire has a resistance R. The resistance of another wire identical with the first, except for having thrice its diameter. What do we mean by that? No? A certain wire has a resistance R. Okay, for number 12, let's go over here. For number 12. Okay, so, okay. A certain wire has a resistance R. So we have here, we have a wire that has a resistance of R. Okay, this is simply R. Resistance R. The resistance of another wire identical with the first. So meaning they have the same resistance. No? They have the same resistance. The resistance of another wire identical with the first. Well, actually, they don't have the same resistance. Sorry. The resistance of another wire identical with the first. So, they are identical, no, with the first, except, okay, so, we have here, having thrice its diameter. What do we mean by that? They have the same material. Let's say they are both copper, and then they have the same length. They have the same length. Except, thrice the diameter. So, we have here, what do we mean by that? No? So we have here a diameter D1. Take a look here. So we have here diameter D1. And then for the second case, so we have here diameter D2. Except for having thrice its diameter. So we have here 3 D1. Let's say this is the first case and this is the second case. For the first resistance, represent that as R. The question here, what is our R sub 2? That is the question in our problem, actually. Take note that they have the same length, actually. They have the same length. They have the same material. Okay, so our formula is R. That is equal to rho L over the area. Rho L over the area. Okay, so we have here, they have the same material, resistivity, of course. That is for the material, the same. Then they have the same length. So, let us represent the rho L by constant K. So, let us have this equation that is our K over the area. What is the relationship of the area with respect to the resistance? Again, just like I've taught you before, no, if that is the denominator, that is inversely proportional. What do we mean by that? Let's say we have R2 over R1. Okay, so we have here our A and our A. How to establish an equation? If that is inversely proportional, if this is 2, this must be 1. If this is 1, this must be 2. That is inversely proportional. If that is directly proportional, if this is 2, this must be 2. If this is 1, that must be 1. Okay, is that clear? Okay. So, let us have this one now. No? What is the area? What is the area? We have here pi over 4 d sub 1 squared. We have pi over 4 d sub 2 squared. So, the pi over 4 will cancel out. Let us simplify further this equation. So, we have here our r sub 2 over r sub 1 that is equal to, okay, by algebra, so we have here d sub 1 all over d sub 2, that is quantity squared. Algebraically, okay, the square here and then the square here will just, we can make this as the whole thing here, d1 over d2 raised to 2. Okay, so we have here r sub 2 that is over the r sub 1. Let us substitute simply r. Okay, so we have here our d sub 1 represent as d1. Then our d sub 2 is thrice. Okay, so d sub 1. So that is quantity squared. Okay, now, the d sub 1 will cancel out. This will just become 1/3 square. By the way, what is 1/3 square? 1/3 x square. That is 0.11, no? This is 0.11. So remember, this is R2 over R. Cross multiply the R, so we'll come up with R2 that is 0.11 R. This is our final answer. Okay? The answer would be letter, okay, letter D. Okay, that's letter D. Let's go over with number 13 now. Okay, number 13. A conductor A has a diameter of 6 millimeter and the length of 200 centimeter. Okay, let us write down all the given values first. Okay, so we have for number 13, there is conductor A. Okay, so for conductor A has a diameter. Diameter of A, so we have 6 millimeter and a length of 200. So this is length of A, 200 centimeter. And conductor B, we have here conductor B has a same temperature and material. Take note, they have the same temperature and material as A, but its diameter. Okay, so the diameter of B is 3 mm. And the length is 1 meter. Length of B is 1 meter. 1 meter. What is the resistance of conductor B? Okay, so the question is the resistance of conductor B. If conductor A has a resistance of 0.01 ohm. Okay, so this is our given values. The question is the resistance of conductor B. Okay, take note that, again, our resistance is equal to rho L over the area. Rho L over the area. Please focus here. Okay, so what is our rho? Our rho simply equal to RA, cross multiply the A, RA over the length. It says in our problem that they have the same material. So therefore, rho A for conductor A simply equal to rho B. Our rho is equal to RA over L. Okay? That is for A. So we have here RA over L. That is for conductor B. Okay? Remember, we may substitute directly all the values given. Okay, let us have first for A. What is for A? What is the resistance for A here? Remember, these are all A. Well, I already put here A. Understood to be all the values here must be for A. Okay, let us substitute. What is the resistance for A? The resistance for A, so we have 0.01, 0.01. And then multiplied, what is the area for A? By the way, we have to make this as pi over 4. Okay, this is diameter of A. Diameter of A, we have 6, right? We have 6 mm. So that is squared. Okay. Take a look here, guys. So this is our length. Our length is 200 centimeter. So we have the length of A is 200. There you are. What about now for B? Of course, the unknown is our RB. What is our area? Pi over 4. What is the diameter for B? DB is 3 squared. The length for B is, oh, by the way, this is 1 meter. Let's make this in centimeter. Okay, there are 100 centimeter per 1 meter, right? Okay. So the pi over 4 here will cancel out, right? Okay. If we are using this calculator, you just have to shift solve. Or, you can go with your manipulation as the usual, no? The conventional way. Okay? Let us solve this. So the answer is 0.02, right? Did you get that? Okay. So our RB is equal to 0.02. Okay, that is for number 13. So our answer is letter A. Okay. Let us go over with number 14. Okay, number 14 problem. A coil has 6,000 turns. There is a coil that has 6,000 turns. 6,000 turns of wire and a resistance of 380 ohms. Okay? The coil is rewound with the same quantity of wire but has 12,000 turns. Actually, there is a second case, no? Let's say you stretch this wire, no? This wire is also this wire, no? They're just the same, no? Okay? It's just that you stretch this wire and you make it as 12,000 turns. So basically you double the number of turns. Okay? The question here, what is the new resistance? Okay, we'll be using the formula. This is equal to rho L squared over V. Rho L squared over V. This is our formula number 2. No, we derived before. Okay? Rho L squared over V. Now, take a look here. What can you say about the resistivity? They are the same. The volume, they are the same. Because this is just one conductor. Okay? So, the rho and the V simply represent constant K. So, take a look here. Our R simply equal to, put here K, so we have here L squared. So, we may say that the square of the length is directly proportional to the resistance. So, how do we set up the equation? How do we set up the equation? That is one relation. Huh? Okay, take a look. That is directly proportional. So, I will go directly with the equation. So, we have here our R2 over R1. That is equal to L over L. That is quantity squared. Take a look here. Since they are directly proportional, this is what I mean before. Since they are directly proportional, if this is 2, that must be 2. If this is 1, that must be 1 also. Because they are directly proportional. If they are inversely proportional, of course, if this is 2, this is 1. If this is 1, this is 2. Huh? I remember in transformer. In transformer, the transformation ratio is equal to this. Any, ENI, any, ENI, 1, 1, 2, 2, 2, 1. That is the relation in the transformer. Any transformation ratio. Any ENI 1, 1, 2, 2, 2, 1. Meaning, the voltage is directly proportional to the number of turns. Okay? Because this is 1, 1 to 2. Okay. What about the relation of the voltage to the current? This is 1, this is 2. This is 2, this is 1. Meaning they are inversely proportional. They are inversely proportional. Meaning, if we have a high voltage on the primary side of our utility company, if this is the transformer, there's a building here which has a bigger wire. The primary here or the secondary? The secondary has a larger wire. Why? Because this is a low voltage. This is low voltage, but it is high current. It has a larger size of wire, the secondary, compare on the primary side. This is low, low voltage, high current, high current. This is high voltage, but this is low current. Again, for the secondary, why it has a larger size of wire? Although this is a low voltage, for example, we have a 34.5 kV, 34.5 kV on the primary side. Let's say that is a three-phase system. Huh? If you have if you have a three power distribution transformer here connected here, so we have a three-phase here. Okay? So, the primary is 34.5 kV. That is high voltage, but it is low current. The secondary is, let's say, 230 volts. Low voltage, but it is high current. This is, what do we mean by this relation? They are inversely proportional. Okay? High voltage, low current. Low voltage, high current. That is inversely proportional for the case of the transformer. That's how we set up the equation. Okay, let's go back to our sample problem. R2 over R1. Okay, so we have here R is equal to K L squared, meaning they are directly proportional. That is on the numerator. That is not on the denominator. Maybe you see here, in here you see the volume. They are inversely proportional with respect to the resistance, the volume, because that is on the denominator. What about now the L squared? That is directly proportional. That's why it is 2, 2, 1, and 1. Now, so we have here, well, we just have to substitute all the values. So we have here R sub 2 over R sub 1. What is R sub 1? So we have here 380 ohms. So we have length 2, so we have 12,000. Then divided by 6,000. So let us just manipulate this one. Go directly with our final answer. What is the answer here? So the answer is 1520. 1520 ohms, no? Did you get that? I want to hear our students there, our participants. Hello, everybody, are you still awake or sleeping? Please do not sleep. Everybody, can you hear me, guys? Hello?
Yes, sir.
Okay, hello, hello. Good morning, good
Good day,
day.
sir.
Okay, to our viewers in our live streaming, no, at YouTube. Okay, so we are discussing the last part of electrical principles, no? Okay, so the answer here for number 14 will be letter, that is letter A. Letter A. Okay? So let's go over with number 15. No? Number 15. Okay? So before that, I want them to copy what's on the board, no, while I am erasing the board. So please go okay? So our student, please copy what's on the board. Well, it's still better that you are following the lecture synchronously. Huh? What do I mean? So it's really better to understand the lecture right away. Although, of course, at home, you have to practice on yourself, no? By solving some problems from the review books, materials you have. Okay, so let us go over with our problem. Number 15. So we have 3 more problems. No? Please listen carefully for number 15. A copper wire whose diameter is 0.162 inch and has a resistance of 0.4 ohm. If the wire is drawn through a series of dies until its diameter is reduced to 0.032 inch, what is the resistance of the lengthened conductor? Assume that the resistivity remains unchanged. So, the resistivity remains unchanged, no, for this problem. Now, we have what we call here a wire drawing machine, no, for this problem. I'll show you the principle of a wire drawing machine. What is a wire drawing machine? All cable manufacturing firm has this machine. So I will discuss the principle of this machine. This is just the side view of the machine. Let's say we have this. This is our conductor. This is just the side view. Okay? So, this is circular in cross-section. So, you will input your conductor here with a larger diameter. Then, once it lives in this hole, what will happen to your conductor? This will decrease its diameter, but it will become longer. That is why it is said in the problem that what is the resistance of the lengthened conductor? Okay, so let us put now all the given values here. So the copper wire whose diameter is, so we have given the diameter, let's say the first one, 0.162, 0.162 inch. That is the first diameter. It has a resistance here, 0.4. Okay, so the reduced diameter is our D sub 2 to be 0.032 inch. That is the reduced diameter. 0.032 inch. What is the resistance? Meaning our R2. Here. Okay, what formula are we going to use here? What formula? This is the formula. So, R is equal to rho V over A squared. Take a look. Is the volume the same? Guys, is that the same? The answer is yes. Theoretically, they have the same volume. What you input here, just the same volume as the output conductor. Okay? This conductor is just this conductor. We're talking only of one conductor here. Okay? So, theoretically, they have the same volume. Although, in practice, of course, you will see some, like a powdered pieces of copper, no? This, because once you input the larger size of wire in the hole of this machine, no? Zzz, okay, so there will be some portions being cut by the machine, no? In the conductor here. But theoretically, we will assume that they have the same volume. Okay? They have the same volume. What about the resistivity? Of course, because they have the same material. This material is also this material. No? Okay? This is a copper. Of course, this will not become gold. Well, that's nice. Your input is copper. The output is gold. Okay? But it will not happen, of course. So, okay, so rho V, okay, this will represent as a constant. That is constant. So, therefore, our R simply equal to constant K divided by A squared. Okay, take a look. What is the relation of A squared to the resistance? Please focus here.
First T.
A squared to the resistance. So, we have here, that is inversely proportional, right? So, we have here, let us set up the equation, R2 over R1, that is equal to, okay, because of the square here, that's why I put here square. I will put here A and I will put here A. Question, since they are inversely proportional, if this is 2, what is this? What is this? Come on, I want to hear Marlo. I want to hear Marlo. Will you spotlight him? Oh, from what you have learned before. If they are inversely proportional, if this is R2 over R1, what is the equation here? Marlo?
A1 over A2.
A1 over A2. Okay, very good.
A2.
Okay? So, if this is 2, this must be 1. If this is 1, this must be 2. Because they are inversely proportional. Okay? They are inversely proportional. 2, 1, 1, 2. No? They are inversely proportional. Okay. So, we have here, we have R2 over R1 that is equal to, okay, for the area now, we have pi over 4, d sub 1 square. We have pi over 4, d sub 2 square. So, the pi over 4 will cancel out. So, this will be our working formula. R2 over R1 that is equal to D1 over D sub 2, D1 over D sub 2 quantity squared. That is, no? So, let us now have this. R2, okay, let us just cross multiply R1. R1, okay, multiplied by D1 over D sub 2. So, quantity squared. Let us just substitute. What is our R1? 0.4. What is our diameter 1? 0.162. Okay, then diameter 2 is 0.032. That is quantity squared. Let us calculate this, guys. Let's calculate this. Oh, by the way, I have a mistake here. I have to correct myself here. So, we have here squared. By the way, so we have to square this, guys. Okay? We have to square this because of the square here. Okay? It's really hard to make a live streaming, especially for the audience, for the education. Okay. On live lecture. Okay. Anyway, there is no take two here. Okay? So, this is a live way of teaching. So, just like in a classroom, no? So, this is 2, 2. We have 2 here because of the square here. Did you get that? Okay. So, therefore, this should be raised to 4. Why, sir? Because 2 times 2 is 4. No? 2 times 2 here is 4. So, put here 4. This must be 4, not squared. Okay? Okay, let us repeat that one. 0.162 divided by 0.032. Okay, then close parenthesis, then raised to, make this 4. Ang kulit eh, no? 4 nga eh. Okay. So, this is 4. Okay, so, put here 4. My answer here is around 262.7363342, right? Did you get that in your calculator also? So let us have this 262.74 ohms. That is the value, no? Okay, what is the letter? Nearest to what letter? That is letter C. We have a 263 here. Okay, did you get that? Can you follow, everybody? Okay, so let us go now with the effects of temperature in resistance. I want you to copy this portion, no? And this portion only, this portion. Please focus this portion here. Go over here. Okay, so let us continue. Resistance, temperature relation. So let us consider this graph. This is a linear graph. This is the x-axis is the temperature that is in degrees Celsius, and the y-axis is the resistance in ohms. Okay, so this is our inferred zero. Okay, so the inferred zero is actually negative in sign. So we just have to put here the absolute value. There is an absolute value. Okay, so this is temperature 1 from the origin up to this point, temperature 1. Considering we have 2 points, point 1 and point 2. Okay, the projection along x-axis, we have T sub 1. Along the y-axis, we have R sub 1. Okay, for point 2, so we have here T sub 2. Then, let us project this vertically. So we have here our R sub 2. So take a look here, guys. Let us get our tangent theta. Where is our theta? In here. Okay, so we have our tangent theta. What is tangent theta? So katowa, opposite over adjacent. So please take a look here. Please take a look over here. So we have R1. This small triangle is similar to this big triangle. Remember that. This small triangle, so katowa. What is the opposite of this small triangle? We have our R1. Opposite. What is the adjacent? That is the magnitude of this from this point up to this point plus this point up to this point. What is the value from inferred 0 to T sub 1? So we just have to add the absolute value of the inferred 0 then plus T sub 1. So we have here for the bigger triangle. Let's take a look here. The bigger triangle, so we have here our R sub 2. We have the inferred 0 plus T sub 2. So therefore, we'll be having this formula, one of our formula here. That is one formula. We have another formula, no? This is our formula. So we have here R sub 2 that is equal to R sub 1 multiplied by 1 plus alpha sub 1. Then we have here alpha T. Okay, remember that our alpha T is what? The final temperature, let's say T sub 2 minus the initial T sub 1. This is another formula. Actually, this being taught in physics class. Okay? R2 is equal to R1 times 1 plus alpha 1 delta T. No? If we have here 1 here, that should be 1. What is our alpha? That is our temperature coefficient. Temperature coefficient. That is our temperature coefficient. So we have this formula for our alpha. Let's say we have here alpha n that is equal to 1 over inferred 0 plus T sub n. No? T sub n. Let's say you have 30 degrees here. Put here also 30 degrees. Okay? So we have now, what do we have? We are ready to solve this problem. Number 16. We have 2 more problems, guys. No? So please listen carefully. Okay, for number 16, please. Okay, for number 16, please take a look. Using the temperature coefficient of 0.0042. 4 per degree Celsius at 0 degrees Celsius for aluminum. Determine the resistance of an aluminum conductor at 62 degrees Celsius if its resistance at 2 degrees Celsius is 7.5 ohms. Okay, so we are given here the temperature coefficient. Let us go first with our temperature coefficient for number 16. So we have our temperature coefficient. Our temperature coefficient is 0.00, 0.00424. Okay? That is per degree Celsius, no? At 0 degrees Celsius. Meaning this is at 0 degrees Celsius. Take a look at this formula. So this is alpha sub n. So meaning, our T sub n here is just simply 0. If this is simply 0, so therefore, we may say that alpha sub O simply equal to 1 over the inferred 0, right? Is that clear? So let us get our inferred 0. Our inferred 0 simply equal to what? 1 over alpha sub O. So let us substitute here. So we have 1 over 0.00424. 0.00424. What is our inferred 0 for this particular conductor? Every conductor has different inferred 0. Remember that. So we have here 1 divided by 0.00424. So the answer is 235.85. 235.85. That is degree Celsius. So 235.35. Now, let us read again the problem. No? Determine the resistance of aluminum at 62 degrees Celsius. Take a look here on the board. No? So determine the resistance of aluminum at 62 degrees Celsius. Let's say this is the 62 degrees Celsius. Let's focus here. So this is 62 degrees Celsius. Okay, determine the resistance. So the question is the resistance at 62 degrees Celsius. It becomes hotter. If its resistance at 2 degrees Celsius, this is just 2 degrees Celsius, is only 7.5 ohms. This is 7.5 ohms. Okay, now, we can make use of this formula. No, I presented to you this formula. So, what is our R1? Our R1 is 7.5. I will put here 7.5. 7.5. And then divided by, we have the inferred 0 to be 235.85. And then plus our T sub 1. What is our T sub 1? Simply 2 degrees. So that is equal to R sub 2. Well, actually, that is the unknown. Then 235.85. And then we have to plus temperature 2. T2 is 62. So therefore, now, what is our R sub 2 here? Let us calculate our R sub 2. So the answer is 9.39. Isn't it? Did you get that value also? 9.39 ohms. 9.39 ohms. Okay? Did you get that? That is 9.39 ohms, no? But wait, there's more. Okay? So I will show you by calculator techniques, no? This is what we call the Powerhouse calculator techniques. Okay. So just press mode 32, no? If we are using to all our non-Filipino audience, so we are using the Casio FX991 ES Plus or even 570 ES Plus, just the same, no? Okay, so let us have this mode 32. Press your calculator. Actually, I'll give you first the formula, mode 32. M is mode. Okay, so you will see here X and Y axis. So you will see here, actually the inferred zero is negative in value. Okay, I have here isotheory. You see isotheory. Okay, so let us have this mode 32 in your calculator. We have X and Y. So what is the inferred zero here? Negative 235.85. So put here 0. What is temperature 1? It is given here. What is temperature 1? We have 2. What is R1? 7.5. So put here 2 and 7.5. Okay, input in your calculator again. Your calculator must be in mode. Press now your mode. This is the mode button. Press the mode 32. Mode 32. So you will see there X and Y, no? So you press now negative 235.85. Then you press equals. You press 2 here. You will see that the cursor will go down here. You press now 2 equals. So you already input these two numbers. And then you press arrow down and arrow right from your replay button. The replay button is the biggest button in your calculator. You see, this is the biggest button here. And you will see here that there is arrow. This is the replay button. There is arrow up, arrow down, arrow left, arrow right. Okay, again, mode 32, you press this, negative 235.85, then equals, then 2 equals, then you press now, arrow down, arrow right. So you press here, 0 equals. Then we have here, positive 7.5 equals, then you press now AC. You press AC, and then the question is at 62, AC 62. Then you press shift 155 equals. So what will be our answer? Again, will you try mode 32 again? Negative 235.85. Equals, so we have 2 equals, so we have arrow down, arrow right. 0 equals 7.5 equals, then you press now AC. Then we have here 62. AC, then you press now 62, shift. So after pressing AC, press here 62, then shift 155 equals. Did you get this value? I want to hear the audience.
Yes,
Please
sir.
unmute. Marlo, did you get that?
Yes.
Okay, what about Leo? Are you getting
Yes,
me,
sir.
Leo?
Yes, sir, I get that.
And-
9.921.
9.39. Did you try in your calculator? So
Yes, sir.
that's very easy. Okay? So that's another method anyway. Okay, let's go over with the last problem. This is our last problem. Okay, the answer is letter A, 9.39. This is our last problem.
Kasi mode 3 pa din yan ngayon.
Okay, let's continue. Everybody, let's continue. After this problem, no, may I ask around 1 or 2 students to ask question, no? If you want to ask something, no, you may do so. Okay, for our last problem, the resistance of a given electric device is 46 ohm at 25 degrees Celsius. If the temperature coefficient of resistance of the material is 0.00454 at 20 degrees Celsius, find the temperature of the device when its resistance is 92. Is 92 ohms. Okay. So, let us plot down again. So, this is our triangle. So, we have here 46 ohm for this device. Let us put here this is 46. Okay, please focus here. This is 46. That is at 25 degrees Celsius. Okay. Find the temperature if it becomes how many? 92 ohms. That is 92 ohms, no? The question is what is the final temperature? That is the final temperature. What is the final temperature? Well, the initial condition is we have 46 ohm at 25 degrees Celsius. That is the initial condition. Okay? But we are given here for the material, the temperature coefficient for number 17. Okay, for number 17, so please take a look here. The temperature coefficient at 20 degrees Celsius is equal to 1 over the inferred zero. That should be plus 20, right? Because of our formula before. Take a look again here. This is our formula before. So we have the temperature coefficient is 1 all over the magnitude of the inferred zero plus the T sub n. Okay? So we already have the value of the temperature coefficient. That is to be, that is what? 0.0000454. So this is 454. That is equal to 1 over the inferred zero, then plus 20. So that is easy in our calculator. Just shift solve, no? If you don't have that calculator, you have to manipulate it. Okay, again, mode 1 in your calculator. So 0.00454. Then you press now alpha, calc. Then you press now the 1 over. Now for the fraction, because this is a fraction. So you have to press this button. Okay. Then you may insert now 1. Then over the inferred zero. Let that be alpha x, no? Alpha close parenthesis. That should be variable x in your calculator. And then plus 20. Okay? Plus 20. Then you press now shift, calc, then equals. Just wait for the value. The value, it will be 200.26, right? Did you get that? So 200.26 degrees Celsius. That is the value. Okay. We are now ready to solve. Using our formula again, R1 over magnitude of inferred zero plus T sub 1, that is R2, magnitude of inferred zero plus T sub 2. What is our R1, by the way? Our R1 is 46 over 200.26. Then plus T sub 1. What is T sub 1? We have 25. That is equal to R sub 2. What is our R sub 2? We have 92 over 200.26 and then plus T sub 2. What will be our answer for T sub 2? Okay, you just have to set up this in your calculator. Okay, and then shift solve, no? So just press shift calc equals. You just have to replace this t sub 2 by x, by variable x in your calculator. The answer would be 249.74, no? 249.74. Degree Celsius. So that is our final answer. Okay, the answer would be letter, there you are, no? Would be letter C. That is our final answer. No? Okay. But wait, there's more. Okay, let's have the Powerhouse calculator techniques. By Powerhouse calculator techniques, so we have here mode 3.2, guys. Again. So please use your calculator if you have there. Although we are already finished, no? So let us just add spice on it. Okay, mode 3.2. So we have here x and y. Iso theory, what is our inferred zero? That should be, put here negative. It should be negative, no? Because we are talking here of the coordinates of this point. What is the coordinates of this point? So that is negative 200.26. That is the x. And its y is simply 0. And then, what is our, this point? The x is 25. Okay, then we have here 46. Press here in your calculator. Then you press AC. And then we have here, press 92. Then shift. Earlier, we make it as shift 155. S is shift. That is shift in your calculator. This time, make it 154. So therefore, the display in your calculator, it will be 92x hat, right? Okay. What is the answer? So let us do that. Come on, let us do that. Everybody, let us do our calculator techniques. Mode 3.2. So we have here, what? A negative 200.26 equals 25 equals arrow down, arrow right. 0 equals 46 equals, then you press now AC, then we have 92, then we have shift 154 equals. So the answer here is around 250.26. Now there's just a little difference, but of course that is just the same, no? It's just a matter of rounding off. So we have 250.26. Unit, of course, that is in degree Celsius. Okay? So if you are finding for the x, shape 154, use the shape 154. If you are finding for the y value, for the resistance, that is shape 155 in your calculator. Okay? That is shape 155. Okay. So, we have, sir, what if we will use the formula from physics to check, no? So, let us have here. This is just a way of checking, huh? Let us just verify. Or shall we say this is the third solution? Okay? So, the formula from physics, so we have here R sub 2 is equal to R sub 1 times 1 plus alpha 1. Okay, so that is delta T. Okay, what will be our reference temperature? What will be our reference temperature? Okay. Okay, let us consider this as way of checking. So that if the left of the equation is equal to the right, meaning this is correct. Well, of course, that's correct. That is being used all over the world, no? Okay, so let us just check, no? I think it's better that always, no, we have a means how to check, no? Okay, so let us have first our reference. The first temperature is what then? Okay, since we are just checking, we will consider the temperature we calculated to be 250.26. There. Okay? By the way, if we are to become more specific, this R sub 2, this is the resistance at 250 degrees Celsius, which is 92. So we have here, put here 92. Is that equal to R1? Okay, please take a look here. What is our R1? R1 is 46. Multiplied by 1 plus alpha sub 1. Oy, by the way, what is our alpha sub 1? Okay. Our alpha sub 1 is, that is our alpha. Remember, we use the 46. If we use the 46, meaning the temperature is 25 degrees Celsius, meaning that is alpha at 25 degrees Celsius. Did you get that? Because we have here R1 to be 46, we use the value 46. So, the corresponding temperature is 25. Therefore, that is alpha 25. But how is this? The alpha 25 is based on the formula that is the inferred 0 plus 25, isn't it? Well, actually, we can go directly here because of our calculator. It's a very powerful calculator. Okay. Okay. Let's go over here. So, we have here 1 plus. Okay. So, our alpha here, 1 over. Okay. What is our inferred 0? The magnitude. We already calculated. 200.26. Put here 200.26. And then plus, we have here 25. 25. So put here parenthesis. Okay. Because of the alpha 1 here, because that is the initial at 25 degrees Celsius. And then what is our final temperature? Of course, the calculated value to be 250.26. And then minus the initial. The initial is 25 degrees Celsius. There you are. No? Okay? So let us manipulate the equation. We have to check, no? The left side is 92 in value. This should also be 92. Please verify. They should have the same value or approximately the same, no? Because there are some rounding up, no? We've done here.
Exact value, sir.
Okay, just the same, right? Actually, that is exact, no? That is exactly 92. So 92 is equal to 92. Therefore, it is checked. Okay? Did you get that, guys? I want to see our audience so that our friends who are watching in our live streaming, no? in our YouTube. Good day, everybody, no? For those who are late tuner. So, well, there's no problem. You may view this one in the YouTube, no? We will upload this right away, no? For today. Okay. So, that is our value. Okay? Okay, will you show to them the our checking? Okay, so, well, that is our topic for today about the electrical principles part 3. Next meeting, no, that will be on Monday, no, and at 9 a.m. Philippine time, no. So we have direct current circuit. We'll start with the calculation of Ohm's law, then we have the Kirchhoff's law. Now we'll discuss to you that the law, the different law, and we promise you so many examples to be solved, no, in detail. Okay, so well, that's it for today, guys, no. Mga kaware pa, no. That is our topic for today. Okay? Thank you and I can sleep now. Okay? So maraming salamat po.
Thank you, sir. Thank you.
Yes, sir.
Okay, salamat sa inyo, no? For those our student in the Zoom class, please do not leave yet, no? Thank you very much to our listener, to our viewers in our Facebook Live. Thank you very much, no? I'll see you again on Monday, no, 9 a.m. Philippine time. So I hope you learned something for today. God bless you all.